Hello and welcome. This is Leetcode 11, container with most water. So let's try to attempt to solve this problem. Here in the beginning, you are given an integer array of named height and the length of n. There are n vertical lines drawn such that two endpoints of each of the ith line are I and 0 and I of height I, which is just saying that giving at the index of the certain the array, so index 1, you should be returning the value of that index itself. You expected a value to turn to you. So here we need to find two lines that together with the x-axis from the container such that form a container such that the container contains the most water. So all we're doing is we're trying to find two lines. Please excuse my vertical lines that we pick that form the maximum water. It needs to be max container. So, and that's what tells us later down the question. It says return the maximum amount of water container can store. So this could be a very critical key to just say, hey, return area. And the area of this sort of question or a container is just nothing but the width times the length. And the width is the distance between two of the lines, and the length, or the height in this case. Let me try to. Nice. Okay. Or height is just getting the technically the minimum height between the two endpoints, because we don't want to take the maximum and have to overspill the water. So we're going to take the minimum height. All right. That being said, we need to come up with the algorithm that does such thing. And the algorithm that comes to mind right away is a two-pointer technique, and more specifically, the conversion type, where you have a pointer starting at the very beginning of the array at index 0, and then you have the right pointer starting at the far end of the array, starting at the length of the array, which is height minus 1. Now, to take more quicker look and understanding about this algorithm and do dry runs, let's go ahead and just move to the next slide here, where I'm going to start taking a look at some examples, or an example where how this algorithm will be affected pretty well. So right here we have the example we had from Leetcode, which is 1, 8, 6, 2, 5, 4, 8, 3, and 7. And again, we have the left pointer and the right pointer starting, well, here it's 0, and then length of height, or height. And there we go, minus 1. So it'll be right here and right there. Right before we do anything, we need to check, hey, while the left pointer and the is smaller than the right pointer, we carry on. But before we start moving down the array, we first calculate what is our current array. And that is done by taking the right pointer, subtracting it by the left pointer, times the minimum height of the pointers. Yep. So that being said, once we calculate the current array that we are at this point, we want to say, hey, max array, update your value based on if the current array, oh, sorry. Let me get rid of that. Max array, or the current array is greater, then we would update. And then at that point, where we're going to say, hey, we want to start moving down the list. And to do so, we need to pick which pointer to go from. Do we go from the left pointer? Or do we go from the right pointer? And the driving logic here is going to be which one was the minimum height. So if height of L is less than height at the right, then we would increment the left pointer by 1, hoping that we maybe come across a much taller height than we had previously. Because here we had 1 versus at the right pointer we had 7. So we would tell the left pointer to increment. So right now we are at the left side, and we're gonna loop back again. As long as our base condition is met, we're gonna calculate, hey, what is our current area right now? Right now, I'm gonna change colors so we don't confuse each other. So the right pointer is at index, I think 7, and this is 1. So this would result into the width being 6. And what is the minimum height between 8 and 7? It will be 7. And 6 times 7 is 49. And given that the current, I don't know why I keep switching to the eraser, I'm sorry. Now, given that the max array before that was 1 times 7, so right now before it was 7, and now it's 49 right here. So the maximum array would update to being 49. And again, we would check, hey, which one is the shorter? Is it the left pointer or the right pointer? The left pointer was actually larger, so we're gonna, let me switch colors. The else if condition, height, right pointer is less than height of the left pointer, then we would decrement the right pointer, hoping we can find something larger. So right now this guy will be transitioned to the right. So right now the right pointer is at 3, and we have the A pointer at L. And we're gonna keep going down the loop until we reach, either we converge or we find something larger. And for the sake of just trying to come to a point where you're going to notice right away is we're going to get to a point that 8 and 8 are the exact same height. So what do we do here? So this point, 3 times, this one's 6, so it'd be 5. 5 times 6 is 5 times 6. Geez, I should know this. 30. Thank you. Jeez. Wow. I am terrible. Okay. So it'll be 30. 30 is still less than 49. So what we're going to do is keep on decrement moving down the array. We're going to hit a point where 8 is now our new height. And 8 times 8 is 40. I think I know that one. And then 40 is still less than 49. But we want to say, okay, well, if the height of the left pointer is less than the height of the right pointer, we would increment. But if the height of the right pointer is greater than the height of the left pointer, we want to decrement the right pointer. But what if we run into a case where both of them are the same height? In this case, we would just pick one of the pointers into incrementing or decrementing. So at this point, given that the last pointer was the right one, we'll just mark it as the right one as well. And then it's going to keep going down. We're going to keep going down the array. And then we hit to a point where the left pointer or the right pointer are not meeting the base condition over here. And we would like to return the max. Oh, there we go. Max array. Hopefully this demonstration was pretty helpful. We're going to jump right now to the code and dive deeper into some technical aspect of this solution. All right, we're back at Leetcode. We're going to try to code up the solution here. So as we said, we're going to go with the two-pointer technique. So let's go ahead and initialize our pointers. So our left pointer is going to be 0. Oh, left pointer and a right pointer. The left pointer is going to be 0, and then the right pointer is going to be the length of the array minus 1. We can also here call out the max array as well, or we could have called it in the loop, but I like to just call it here. It would be a bit more smoother in my opinion and cleaner. All right. So while left is less than right. Here, as we said, we're going to compute what is our current sum. So, current array, which is the width, which is the right pointer minus the left pointer, times the minimum height between the left pointers and the right pointer. And the max array is going to be not just taking the maximum of the current max array and the current array. We will only replace the max array if the current array is greater than the existing value that it holds the maximum array. And now we're going to go through that check where we're going to decide whether to decrement the right pointer by 1, or we're going to increment the left pointer based on which one has the shorter height. So we can try to find something that is a bit taller. So if height of L less than height of right, then we're going to tell the left pointer to increment by 1, else if height the right is less than the height of the left, then we're going to decrement the right pointer. Else, and this is the else condition where both heights are equal, and that comes down to here right at number index 1, and I think this is index 6, am I mistaken? Where both of them are 8. At that point, we can just pick one of the pointers here. Since we've been using the right pointer, we'll just use the right pointer again. And then we would like to return the max array. And that should be, let's try to run it. Perfect. We passed our local test cases. Let's try to submit it. And then, voila, it worked. I mentioned this in the description of the algorithm, but the time complexity of this 2-pointer should be O of n, and space complexity should be O of 1. And to make sure I'm not lying, here's your time complexity, O of n, and memory is O of 1 as well, constant, because we're not using any type of data structure to store any of our data or manipulating the existing input. So hope this was helpful. Feel free to drop any questions. I'd be more than happy to answer. I know I've heard there's more than one way to do this, but this is the one way that I felt where 2-pointers will make your life a lot easier to do so. So I hope you have a good one, and take care.